Hey guys, we're here at Boot Mode. I want to show you our new REV2 board. So we've got the REV2 board in the enclosure. The enclosure is an IP66 waterproof enclosure. To get started, the REV2 board sits in the car. We made a bracket for it, a mounting bracket that mounts on the passenger side of the car. It goes on existing screws that are there. The way it mounts the board sits kind of like that. Basically, and the top and bottom have mounting holes for these little screws that then hold the board in place. Once the board is mounted in the car, you can proceed with the installation of its harness. This beast here of a harness is a motorsport grade harness, DTM connectors for all the inputs and outputs that the board has. We were initially going to do just the most popular two because these take time to build, but at the end we decided it was better that everybody had a connector at the end, and then if you're actually using that input or output, you could build yourself a small little 2-wire or 3-wire harness to connect that sensor or whatever it may be. Some of these sub-harnesses, we call them, we provide with the board for things that you may need. But to walk you through what's in this harness, we've got this Motorsport waterproof connector that is the main connector for the REV2. That's the one that plugs in over here. And it has a seal inside, so you want to be careful when you're putting that in, that the seal, is not broken. That's what seals away the pins in the board and protects it from water damage. The next thing that's key here is this enclosure that inside of it has a small fuse and a relay. The board doesn't use a lot of power. It does not power, for example, your fuel pump, but it controls your fuel pump through, an automotive relay. Just something to keep in mind when you're doing the installation, when working with your tuner, is that the REV2 board outputs are always pulsed grounds. Moving on, these little DTM connectors here that are nearest to the REV2 board, these are your outputs. There are labels on it. We have documentation on our wiki that outlines what each of these short labels represents. For example, LPFP is the output for your low pressure fuel pump, and so on. There are 1, 2, 3, 4, 5, 6 outputs here that are in this bunch. And then there's one more output here, an OEM looking connector. So what this is a connector for your exhaust flap. This is optional. You don't have to connect this. What we did use this for is direct control of your port fuel injectors. DME pulses the exhaust flap output, which basically is carried all the way to the exhaust flap. If you disconnect from your flap, connect this into it, that pulse for your injector is going to travel down this harness and go into the REV2 board. And then the REV2 board simply replicates that to the port fuel injectors. Moving on down this harness, we have this part of the harness, which has 2 extra pins on it. So it's for FlexRay. This is the only part of the harness actually that goes into the cabin. It goes through the firewall on that side. There's a little hole in the firewall, goes under your glove box, and it goes down to the body domain controller, BDC. On connector 8, there's FlexRay pins there, which you depin, put these in. The other ones go here, and we'll show that in the installation video. Moving on with the harness, the next thing here that we have is a wire that has PWR on it. That's for power. That goes to your battery. So moving further down the harness, we've got the side that basically goes across to the driver's side, and that's where all of our inputs are sitting. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 inputs. For example, the nitrous bottle pressure sensor. If you're running nitrous, I'm not going to go into too many details, but maybe you want to monitor your nitrous bottle pressure and not spray when the pressure is too high or too low. And many other sensor inputs. We'll go through those in separate videos. We'll go through the control strategy in separate videos, but this is just an overview to show you what is all that we have in this harness. Moving down further on this particular harness, we've got 6 connectors for the port fuel injectors. So moving on further down the harness, we've got this part here, which is labeled with crank. It goes to your crank position sensor. So this basically stays on the driver's side. This one dips down between the engine and the firewall, goes down to the crank. So you're laying down then these injector connectors along the top of the engine, and then you're going across the top of the motor and plugging in the intake cam sensor. You plug and play with your OEM one. You've got a ground connection, which is in the front of the motor. There's basically a screw there that you put this in, and that's a great ground to have. And then at the very end, you've got these connectors here. This one here is plugging in into your PCV circuit so that you have ignition power to the board, the ignition power which triggers this particular relay. And this connector here goes to your factory vehicle harnesses bank 1 electronic wastegate controllers connector. So when you go with bigger turbo setup, Precision, Garrett, whatever you have in there, that turbo has a wastegate that is controlled with a max solenoid, and that max solenoid can be controlled with DirectPWM, no network protocols of any kind. You can pulse the output for the electronic wastegate connector, and that basically pulses an input on the REV2 board, which pulses the max solenoid. So we've got a bunch of these optional sub-harnesses that you can include when you're buying the REV2 package. The basic REV2 package includes the board, includes the main harness, includes one of these ethanol sensor sub-harnesses. It does not include an ethanol sensor. Optionally, with the REV2 package, you can order a sub-harness. This plugs into one of the inputs. The inputs, again, are on this side of the harness. You'll find an FP label for fuel pressure. This is what you need to run your port injection. It's an option because you can run your port injection with the factory fuel pressure sensor that's on the car. Factory fuel pressure sensor is on the DI side, so it's not ideal to run your port injection that way, especially if you're pushing power. It is highly recommended that on your fuel system, like we've done in some past videos, we showed you one setup from Precision Raceworks. It separated the main DI line, left that alone actually, the stock DI fuel line, and it provides a separate feed for your port injection for the rail that's on top of the intake manifold. So in that line, probably have some kind of a fuel pressure regulator. On the Precision Raceworks setup, you have a bung there for one of these fuel pressure sensors. You can put that there, run this up the engine bay, plug it into the input for fuel pressure, and the tuner can then set that up for you on the DME in your map. The recommended fuel pressure sensor that we use is a 150 PSI one, or 10 bar for fuel pressure. So I've mentioned the flex fuel sub-harness that you receive with the REV2 board. You have basically the ability to run any kind of a flex fuel kit that you like. We provide a boot mode flex fuel kit as an option that you can add on. And with the REV2, we are introducing a new, simpler kit that when you're running a port injection setup, a lot of the fuel will come from the port injection side. Other than our standard kit, which has the amazing bypass built in, which is great when you're on a direct injection only setup, and we recommend it. The new, simpler setup that is more basic, doesn't flow as much, but it is very easy to install. It has the ethanol sensor there, and it has these two fittings from Precision Raceworks. They're 360 fittings because you can put them together and they're 360 there. But basically, the factory line goes into here, fuel goes through here, goes through the sensor, comes back out and goes to your fuel pumps. So this goes on your DI side, and you plug in this little harness on this side, and this goes to the E85 input on the REV2. One of the optional add-ons that you could add to the REV2 is this coolant pressure sensor fitting. It goes into upper radiator hose. This basically just wedges in on the hoses. You can run that pressure sensor into the CP input on the REV2 board. REV2 sends that voltage data over to the DME. And then we have this other fitting that we came up with for everyone that isn't running an aftermarket intake manifold. Basically, you need to get that boost reference from somewhere. There's this fitting that goes on your vent line that goes across the intake manifold. Basically, this sensor then can plug in over here, screw it in, and this plugs and plays with the T-map sensor, the factory T-map and the factory vehicle harness, and you calibrate this on the DME side. So this doesn't connect to the REV2. You've got the REV2 installed at this point and everything's hooked up. You're excited, you want to get going with it, you want to go to your tuner. What needs to happen is the DME needs to be flashed with a CustomROM version 2 map. It's a full flash. If you've got a DME that is OBD unlockable, like some of the pre-LCI X3M, X4M, you can probably just go in there and flash a CustomROM V2 map, and it's a full flash. It's gonna take you a couple minutes, 2 minutes maybe. The guys that have the cars that Femto has unlocked, fortunately, you have the only option is to send your DME back to Femto. They will load our CustomROM V2 changes along with the unlock, and basically once you get it back in the car, you can get the tuning. There are things in the CustomROM V2 that don't require the REV2 board at all. Some of those things are, we've got custom boost control, custom launch control, a new flex fuel strategy that is completely different from our version 1 implementation. It's a lot more powerful. We've got a whole bunch of safeties that you can plug in that basically fail-safe you from different things that are not related to the REV2 directly. For example, if you get knock, ignition timing correction in your logs. In the tune on the DME, you can set up the amount of knock that you want to allow before check engine light starts flashing. And then as last point, what we added was something that will save tuners a lot of time when custom tuning, when familiarizing themselves with the tables in the DME. It's called live tuning. You open up the editor, any of the tables that are in there, you can go in, and while at the standstill, you can change any of the tables that are there in real time, do a pass, come down to a stop, review your log, make the other changes, whatever you need, and keep doing your revisions that way, instead of making the revision, saving it, flashing the car, having all this downtime, and then running it. So live tuning is something that is literally making tuning 1,000 times quicker on the dyno. So I'm just gonna walk through some of the outputs on this side. One of the outputs that we've got on this is the line lock. This is really useful when you're setting up your launch. So custom launch control engages after you do a nice burnout. So line lock lets you burn out your tires very easily and in a controlled way. The next connector we've got here, it says EBCS. That's an electronic boost control solenoid or your max solenoid. So you connect that over to it directly. The next one says LPFP. LPFP is the low pressure fuel pump. We've got the next one here is a methanol pump. If you're doing methanol water injection on your car, in some cases you're gonna have the methanol pump and you're gonna have a methanol solenoid. And the way that you control that sort of a setup typically is you run the pump just like you run your fuel pump at some constant pressure, and then you pulse your meth solenoid with some duty cycle for progressive meth control. So we've got a methanol pump and a methanol solenoid output over here. And one of the other outputs, it says NOS on it. The nice dangerous nitrous. Could be dangerous, but it's not so scary with a REV2 and CustomROM V2. We've got a lot of tables to set up your nitrous. It's not just a button somewhere. It's not just some table that says, okay, this RPM and boost, spray this much nitrous. There's a lot of setup for the nitrous activation window. A lot of switches where you can set, minimum pedal. You can set per gear where you want the nitrous to activate. If you want it to activate only on certain map slots, you can do it progressively. All of this is combined into one really elaborate nitrous control strategy, and we're really proud of that particular feature because it's been built out to the max. And on the other side of the harness, we have all of the various inputs for all kinds of sensors on the car that you can add. There are actually 9 inputs in total. One of them is NOS-P, so it's actually nitrous bottle pressure. So one of the things in that nitrous window setup that I mentioned earlier is the ability to not trigger nitrous if your bottle pressure in the nitrous bottle is below some value or above some high value. So the next input here says CP. It's for coolant pressure. So it'll need one of these coolant sub-harnesses. You can make one for yourself. A pressure sensor at the end, and you would put it into the coolant line, into the coolant system somewhere. This is one of the optional fittings we provide. Basically sends the voltage value of the pressure sensor through the REV2, sends it over FlexRay to the DME, and then the DME, the map, has a table that's set up with when to trigger limp mode for too high coolant pressure. That sort of strategy is employed for any other input that is of that kind. One of them that's very similar to that in terms of fail-safe strategy. If your turbo on the compressor housing has a fitting for a speed sensor. So a lot of the Garretts have this, some of the Precision turbos have it. You could add it on some of them as well as an option. But basically, if you have a speed sensor on your compressor housing that looks at the compressor wheel, the tuner can set that up in the tune and basically calibrate the particular turbo's compressor wheel and that sensor to monitor the speed that the compressor is spinning at. All the manufacturers, most of them, publish these specs for maximum compressor speeds. You have efficiency, compressor maps, and all of this stuff that's useful when you're tuning. You could monitor this in your logs and look at where you are on the efficiency islands for your turbo. And at the end of it, you can say, okay, well, my manufacturer of this particular turbo says 110,000 RPM is the maximum speed that they're comfortable with. So I'm going to set my fail safety for 110,000. So if you get a boost leak and your turbo is trying to overspin, this sensor will pick that up, and the tuner can set up a fail-safe to shut everything down and give you a code which says you're overspeeding your turbo. One of the other inputs has a label on it, LRHS. It's for laser ride height sensor. So if some of you recall, we had a wheelie control as one of the features in REV2, and unfortunately we didn't get the complete wheelie control, but that'll be in the next version. Instead of that, we did the custom launch control, and we think that most of the S58 guys, we haven't seen a single car wheelie yet. I'm sure that'll happen eventually, but instead of that, we used that time to finish custom launch control, and I think most of you guys can actually make use of that feature. So for now, the laser ride height sensor, you can, grab one from Haltech, for example. It's not cheap. Plug it in, install it on the bottom of the car. For now, you can data log the ride height, where the car's going, how it's lifting. For now, it's data logging only, not very much use out of it other than that. The next one, pretty self-explanatory. It's got E85 on it, so it's for your ethanol sensor. Once you plug the ethanol sensor in, the frequency and the pulse width are sent over to the DME. The DME does the ethanol content analysis and figures out what ethanol content and what fuel temperature your ethanol sensor is seeing, and builds all of the flex fuel related strategies out on the DME side. One additional thing about the ethanol content sensor is that there is a code that can be configured that if your sensor dies and it's not providing any input, the DME can actually trigger a trouble code and basically let you know that your sensor is malfunctioning. The next one here has to do with methanol injection. It has ML on it, it's for methanol level. So if you've got a methanol tank, it has a level sensor. That level sensor has to be one that has basically 2 wires on it. It's not a powered sensor. So it's one of those ones that when the fluid level goes low in the tank, it basically connects to ground. So that ground signal, if it's fed back into this methanol level connector, will have that signal sent over 0 or 1 to the DME, and the DME can trigger a failsafe for low methanol level in the tank. The next one here, we have FP. It's for fuel pressure. I've showed you guys the sub harness over here. So this guy is the one that connects over here, and then the actual pressure sensor goes down into your preferably port injection feed line. That's where it should go. On our car here, it goes on the bottom of the car. We've got a fuel pressure regulator and one of the MPT ports on it. We can plug that in. One of the other inputs is for methanol flow sensor. It says MF on it. Basically, it allows you to monitor your methanol flow as it flows. So you have to put that methanol flow sensor in your meth line. So when the pump and the solenoid are flowing, it's good to know that actually there is some flow happening. Typically, your flow sensor sits in between the pump and the solenoid. If you have no solenoid, it's just before the nozzle, and it's a great way to know that your methanol is actually sending some fluid to the motor. You can see that in your data logs. And last but not least, there's an input for EBP, which is exhaust back pressure. Basically, you would need a kit that installs on your exhaust manifold somewhere pre-turbo. So typically, we would add a bung somewhere on the collector or anywhere you feel comfortable. You can take in exhaust manifold back pressure from there. So you can't go directly down to the exhaust manifold with something like this, right? Because it would melt very quickly and the sensor would die. You need some kind of a relocation kit for the actual map sensor, usually made out of stainless. It's a line coiled, and it puts some kind of a canister that equalizes the pressure pulses from the exhaust manifold. And then on the other side, you would put in one of the pressure sensors and then plug that into the EBP input on the harness. One more thing I want to show you is this little rubber sleeve that covers two more connectors. These connectors here are for exhaust gas temperature probes. So we're gonna have a lot of content coming out about the REV2 and about CustomROM V2 and all of the features. This is just a preview to show you the board, to show you the harness, some of the stuff that basically connects to it, and we wanna show you the install. But we're gonna be going into port injection, how that's tuned with CustomROM V2, what is in the editor, what for any of the control strategies for nitrous, for max solenoid, for a line lock, how that's configured, custom launch control. All of these things have a lot of detail in them, and they may not be relevant to most of you because you're just going to be getting this installed, getting a tune, and then, go out there and have fun. It'll be mostly for tuners that are looking to find out more info, how we do things. So that's where that focus is gonna go. We're gonna get into the install now. This car has only a subset of things that will be connected. Some of those things are required, and those required pieces will be shown with required on the video. The optional connections that we're going to be making for this car will be labeled as optional. Everything else that we leave unplugged, you can hook up as needed. So let's get into the install video. Head over to the trunk and undo the battery ground terminal. Next, mount the controller bracket on the two studs underneath the cowl passenger side. Tighten the bracket with the two nuts provided in the kit. Mount the controller on the bracket using the 6mm bolts provided in the kit. Take the REV2 harness and lay it in the back of the engine bay. Remove the two screws on top of the plastic bracket on the passenger side. Lift the plastic piece and run the harness underneath in the spot where the rubber grommet sits. You can go ahead and reinstall the plastic bracket. Go to the battery terminal distribution block, take one of the screws off, and run the power wire underneath the terminal. Make sure you tighten the screw back on after reinstalling. Make sure to reinstall the nut on top of the terminal again. Proceed to remove the factory harness that runs along the driver's side of the valve cover. Proceed to install the injector harness by sliding it in from the back underneath the wires, OEM wiring, and pull the harness towards the front. Go ahead and install the connectors onto each of the port injectors. Take the harness with the cam label on it and run it the same way as the injector harness towards the front of the motor. Proceed to disconnect the intake cam sensor in the middle of the valve cover and connect the REV2 harness into it. Now you can plug the OEM harness back onto the valve cover. Send the remaining two connectors for EWG and ignition on power down in between the engine and the Valvetronic motor. Find the E8 bolt on the block, remove it, and place the ring terminal labeled ground underneath it, and reinstall the bolt. Connect the PCV heater circuit to the gray connector on the REV2 harness. Next, reach for the back of the engine bay. You'll find the crank labeled harness, single wire harness. You send it down to the back of the engine bay. This connector can be plugged in from the top, but it is easier from the bottom. Next, take the provided plug-and-play map sensor harness and proceed to disconnect the OEM TMAP sensor. After it's disconnected, you're connecting the plug-and-play TMAP harness into it and connecting the new map sensor that's provided in the kit into a position on your intake manifold that works best. For those of you running a flex fuel kit, you'll want to take the flex fuel kit sub-harness that we provide with the REV2, plug it into the flex fuel sensor, and plug it into the E85 input on the REV2 harness. For those of you with a fuel pressure sensor, you can connect the fuel pressure sensor into the FP input on the REV2 harness. As an optional add-on, you can install the coolant pressure sensor adapter on the upper radiator hose, install the sensor on top of it, and connect the pressure sub-harness from the sensor to the REV2 input called CP. For those of you with an aftermarket turbo like a Precision or a Garrett, you will have a Max solenoid. You will connect that Max solenoid to the EBCS output. Proceed to install the FlexRay harness through the firewall and into the cabin. You'll take the FlexRay harness and disconnect the connector 8 on your BDC. Pins 31 and 32 on the black sub-connector need to be depinned and plugged into the provided FlexRay harness. Pin 31 wire from the black connector goes into the pin 2 on the connector provided on the REV2. Pin 32 wire on the original connector goes into the pin 1 on the black provided connector from REV2. Insert the sub-connectors back into connector 8 and reinstall in your BDC. Run the exhaust flap long harness into the cabin and run it to the back of the car along the passenger side. You'll find the rubber grommet on the right side of the battery. Proceed to remove the grommet and insert the exhaust flap connector. For those of you with aftermarket fuel pumps, you'll want to run the long harness from the REV2 output back all the way to the trunk. You're connecting to the LPFP labeled output. On our G80, we have 2 fuel pump relays, one for each of the fuel pumps in the tank. We have trigger wires connected to DTM connectors for each of the relays, and we have a harness that splits from the REV2 into these 2 connectors. On our G80, we also had some additional equipment installed. We have the exhaust back pressure sensor. You can see in the video, we are showing you the relocation kit for the back pressure sensor. On our G80, we also installed an EGT probe on the exhaust manifold. You can install it on any of the provided connectors on the REV2. And finally, at the front, proceed to connect your REV2 connector. Go to the trunk and reconnect your battery.